Let's do this review on sections 1.7 to 1.11, sorry. This is the first video. Here they're asking that we are given we have to write limit statements for these rational functions, left and right and behavior as such. So the left hand behavior is, of course, we can see that if x keeps going towards the left side, this function tapers, flattens at 1. And likewise, if x keeps on increasing towards the right side, this function also flattens again at 1. So I can say that the left-hand limit x approaching to negative infinity of the function fx is just 1 because that's where it flattens. And likewise, the right side x approaching to infinity of fx is also 1. That's what we have. All right, for gx, I think the same thing, but 2, because they're asking the left and right hand behavior. See, had they were asking the limit statement about the vertical asymptote, that would have been different. Then we would have seen that where the function is going immediately on the left of 4 and the right of 4. But they're asking left and right end. So end is again when x is approaching to infinity, negative infinity, sorry, of g. So the function is again going to 2. And when x is approaching to infinity of gx, then the function is also approaching 2 because, yeah, it flattens at 2 on both the sides or both the ends. All right, over here, this is a case of horizontal asymptote, of course. So if you remember, we discussed that if in a rational function, if the degree of top and bottom is same, then the answer is just the ratio of the leading coefficient. And in this case, indeed, the degree of the top is also 2, bottom is also 2. So the ratio of the leading coefficients will be 2 over 3. So it doesn't matter whether I go towards the left end or the right end, the answer will be same. So even whether you go to negative infinity or whether you go to positive infinity, the answer is 2 over 3. Over here, let's find out the degree of the top. It is, or the leading term on the top, it is 2x square. And the leading term at the bottom will be x square from here, because there's a square here, and x from here. So x squared times x is x cubed. That's a leading term. And we learned that if the degree of the denominator is more than the numerator, then the horizontal asymptote or the end behavior, it is approaching to 0. So whether it's going to negative infinity, it will go to 0. If it is going to positive infinity, then also it is going to 0. Same situation over here. However, in this case, the degree of numerator of the top is more than the bottom. And whenever that happens, the horizontal asymptote does not exist. But here we cannot just write does not exist, because they want us to be specific whether does not exist means what. Is that plus infinity or minus infinity? So that's when we need to take the ratio of the leading terms and decide where it is approaching. For example, in this case, it is negative 2x raised to 4 over 5x square, which can be written as negative 2x square over 5. And now it makes sense that whether if x approaches to negative infinity, let's say I'm going towards the negative side. So it doesn't matter even if x is going to a negative number, because x squared will make it positive. So this number will be positive, and positive times negative is negative. So actually it is going to negative infinity, right? Because we know it has to go to either infinity or minus infinity. And we are just trying to find the sign here that even if x approaches to a negative number, this square of that will be positive. And because of this negative, overall it will go to a negative number. And likewise, limit x approaching to positive infinity of Rx. If we go towards the positive side, then also the same situation, because positive square is positive and positive times negative is negative. So it will also go to negative infinity. I hope that makes sense. Okay, here we have the leading term as 3x squared times x on the top, and here we have 2x whole square at the bottom, which means that it is 3x cubed. I'll just write over here. It means that it is 3x cubed, and here it is 4x square. So of course, sorry, yeah, 4x square, correct? Yeah. So that's what we have, and so here also the degree of the top is more, so the answer is definitely does not exist, but we want to be specific. So if we simplify this, we have 3 over 4x, and now this is a little different from the left one, right? Because if x now approaches towards the left side, negative infinity, this will become a negative number because x is going to a negative side. So this will be negative infinity. And likewise, if x approaches to a positive number or a positive infinity, this will become infinity over here. Okay. Here we need to write the limit statement describing the relationship between the output and input. Okay, so verbal descriptions are given. The input value decreases without bound. We need to write the limit statement for this. So input value decreases without bound. Input value means x value, and x values, if it is decreasing without the bound, then you can see that this is approaching to a slant asymptote, correct? This is approaching to a slant asymptote. But eventually, what is the y value? Because they are asking what is the output value. After all, obviously, it is getting flattened about the slant asymptote, but the y value just keep going on and on to negative infinity. After all, right? It's going down, it's descending. So I'll say that limit of x approaching to negative infinity of f of x is actually negative infinity. And here, if the input value increases without bound, if the input value keeps going on and on like this, then the graph becomes flat over here, and it becomes 1. So I'll say that as limit x approaches to infinity of gx, it becomes 1. The graph of h and k are given below. We have to find the limit. All right. So 2 minus is 2 is somewhere over here. It's exactly here. In fact, a little on the left of 2. A little on the left of 2 will go to negative infinity side. Negative infinity side, right? When on the left of 2, it is going down, so it's negative infinity. But 2 plus means a little on the right. It is approaching on and on upwards. It is increasing, so it's going all the way to infinity. 3 minus means a little on the left of 3. A little on the left of 3 means it's just over here, which is obviously closer to 3, right? It's approaching to 3. If we approach 3 from the left side, something like this, it is going to 3. And if it is approaching 3 from the right side like this, it is also approaching the same number, which is also 3. It makes sense because this is just a hole, right? And whenever we have a hole at that point, the limit at that point is basically equal to the value, the functional value it would have had there was no hole, if that makes sense. Then we have 5 minus and 5 plus. So the same situation, 5 is a whole. So at 5, we would have negative 2, but the limit, but we have limit. So limit will also be the same number, which is negative 2. So this will be negative 2, and this will be, oh, they're not asking 5 plus, so that's about it. Then they're asking 3 plus and 3 minus. This is VA. So 3 plus is a little on the right of 3, which is going on and on, increasing, so it becomes infinity. And then they're asking negative infinity. So when x is going to negative infinity, we can see that y is increasing on and on. It's going to positive side, positive infinity. And when x is going to negative infinity over here, sorry, x is going to positive infinity over here, you can see that the function function is decreasing. It's going down, so it will become negative infinity. Right. All right, let's talk about this one. So for each of the following, we have to write the left and the right end statements for fx as x approaches 1. All right, and first we have to figure out that whether 1 is a whole or a VA. So we can clearly see that here 1 is a whole because x minus 1 factor is at the top and bottom with the same degrees. So the way we figure out the limit is we just cross these out. We just cross these out, and then we just replace x with 1, right? We replace x with 1. So basically, we find f of 1 after canceling the common factor, which is 1 plus 5 over 1 plus 2. It's not f of 1 as such because it's the simplified version, but you understand that I've simplified it and then I'm putting 1. So it will become 6 over 3, which is 2, which means that the left hand limit of at 1 of the function is also 2, and the right hand limit 1 plus of fx, say likewise it is also 2. Right. Here we have 1, but 1 is a VA over here because there's no factor on the top, right? So it's obviously going, it's obviously does not exist, but we need to figure out whether that's plus infinity or minus infinity. So for that, when x is approaching to 1 minus a function, 1 minus means a little less than 1, right? Probably 0.9, because I'm just interested to know the sign of it. I know it has to be infinity, but is that plus or minus? That's all I want to know. So 1 minus is maybe 0.9. So 0.9 minus 2 is a negative number. I'm going to write that. 0.9 minus 2 is a negative number. 0.9 minus 4 is a negative number. 0.9 minus 1 is a negative number. And 0.9 plus 2 is a positive number. Three negatives will become negative. So the answer is negative infinity for 1 minus. What about 1 plus? So limit x approaching to 1 plus of fx. Now 1 plus means a little more than 1, maybe 1.1. So 1.1 minus 2 is a negative number. 1.1 minus 4 is negative. 1.1 minus 1 is positive. And 1.1 plus 2 is positive. So double negative becomes positive. So the answer is infinity. Likewise, over here, x approaches to 1. This is also a VA, and we'll do the same strategy over here as well. Limit x approaching to 1 minus of the function, and limit x approaching to 1 plus of the function. Any number less than 1, a little slightly less than 1, maybe 0.9. So 0.9 plus 3 is positive. Positive. 0.9 plus 1 is positive, and 0.9. Actually, I don't even need to bother about this because that's a whole square, perfect square, right? That's never going to be negative because 0.9 minus 1 is a negative number, but negative square is positive. So this is also positive. But remember that there is a negative already over there. So although these three positive will be positive, but this negative is going to make everything negative. So this is going to negative infinity. And if we put 1 plus, then 1 plus is going to be positive, maybe 1.1, positive, positive, positive. But again, there is a negative. So this is going to make it negative infinity as well. That's how it works. All right. For each of the following, describe and label any x values where the graph as a whole or VA. All right, that's easy. We have done this before. Clearly, x minus 2 is a whole because that's a common factor with common degree on top and bottom. So I'm going to first write whole. This is VA. All right, so x equal to 2 as a whole, and x equal to negative 3 is a VA clearly because the degree of the denominator of that factor is greater than the numerator. So x plus 3 is equal to 0, which means that, you understand, right? X plus 3 equal to 0, which means that x is negative 3. That's a VA. And for whole, I can definitely show this step. What I did is I just set x minus 2 to 0. So I concluded that x is equal to 2. Likewise, over here, x plus 1 is clearly a VA because there is no factor on the top. So x equal to negative 1, that's what I have. And x plus 2 is a whole because the degree of, will return a whole because the degree of numerator is more than the denominator. That's the condition for whole. So I will say x equal to negative 2. And finally here, oh, unfortunately, we cannot conclude anything right now because we need to factorize this. So let's do that. Let's do the factorization. So x squared taken as a common factor, I'm left with x minus 1. And this can be written as x plus 1 whole square because the denominator is just a perfect square. And actually, this turns out to be on the easier side because I know that there's no whole. There is no common factor on top and bottom. So wholes, and for whole, I'm going to say none. And for VA, definitely there is a VA because this is the only thing at the in the denominator and there's no common factor as well. So x plus 1 equal to 0, which means that x equal to -1. That's going to be the vertical asymptote. So these are our answers. All right. Solve the following inequalities using the interval notation. So the way we used to do these questions is first we'll make sure that all the leading coefficients everywhere are positive, which it is already. Then we'll make a number line and we'll plot the zeros. So x equal to 3 and x equal to -2. That's what we have. Then we'll choose numbers. For example, any number greater than 3 that you like, maybe 100. So 100 minus 3 positive, 100 plus 2 positive. So this is positive. And if you remember, we learned a shortcut that if all the powers of the factors are odd, then you just toggle the signs. This is with the power of 1, this is with the power of 1. So this is with plus, minus, plus. That's about it. We want less than equal to 0, which is definitely this. But be careful whether to include -2 and 3 or 3 or both. Don't just include both blindly because this is a rational function and denominator equal to 0 is not really allowed, right? So -2 is not allowed, but we definitely allow 4 over here, 3 over here because 3 is just making the numerator 0, which is absolutely fine. But -3 is not allowed because it is making the denominator 0. Right, likewise over here, I'm going to make a number line. All the leading terms are positive, so no problem about that. The roots are going to be -2, -1, and 1. Any number greater than 1 may be 100. I think I don't even need to worry about this because this is a perfect square. So it is always going to be positive. And if I put any number greater than 1, this will be positive, this will be positive. So this is positive. Any number between -1 and 1 may be 0. So this is positive, this is positive, so positive. Any number between -1 and -2 may be -1.5. So this is positive, but this is negative. So it will be negative. And any number less than -2 may be -100. So -100 will make both negative. So double negative is positive. X is greater than, this is greater than 0 means it is negative infinity to -2, and obviously no terminal points are included because 0 is not allowed. -1 to 1, union 1 to infinity. It's important that you separate at 1 because like I said, 0 is not included, so we need to separate the inequality at 1. Likewise over here, unfortunately, we need to factorize this first. So this is pretty easy. I think x minus 4x plus 3, if I'm not wrong, over x squared should be greater than equal to 0. I'm going to make a number line. I'm going to plot points, which is -3, 0, and 4. Over here, anything greater than 4, anything greater than 4. And by the way, I'm not really bothered about x squared because that's, always positive. So anything greater than 4 may be 100. So positive, positive. So positive. Anything between 0 and 4 may be 1. Negative, positive, which is negative. Anything between 0 and -3 may be -2. So negative, positive, which is again negative. And anything less than -3 may be -100. So negative, negative, which is positive. So greater than 0 means negative infinity to -3. Can we allow -3? Yes, because it is at the top. Union 4 to infinity. Can we allow 4? Yes, it is also at the top. So this is our answer. The last one talks about, be careful. The leading term is negative on the top. So I need to change that. So I will first multiply negative sign on both the sides. And x plus 2, x minus 4 whole square is greater than 0. So inequality switches, and then I'm going to plot a number line. The number line is going to be -2, 0, 3, and 4. I will not really check these two because these are squares, so they are always going to be positive. So just the other two factors. Anything greater than 4 may be 100, so obviously this is positive. Between 3 and 4, maybe 3.5 is still positive. Between 0 and 3, maybe 1 is still positive. Between 0 and negative 2, maybe negative 1. Okay, now this will be negative and this will be positive, so negative. And anything less than negative 2, maybe negative 100, so both negative, which is again positive. I need greater than 0, so it should be negative infinity to negative 2, union 0 to 3, union 3 to 4, uh, and union 4 to infinity. It's very important to separate that at 3 and 4 because the equal to 0 is not allowed.